Me, good afternoon.
Good afternoon. Okay.
One second.
We saw your presentation.
This
It's a
this
good
is my
place.
presentation. Oh, can you see my presentation now? Good afternoon. My name is Vitaly Alexeiko. I'm a PhD student and I'm pleased to present our paper titled Climate Parameters Monitoring in the Context of Natural Disasters Forecasting. We represent Khmelnytsky National University. The authors of this study, Professor Tetiana Hovorushenko, Dean of the Faculty of Information Technologies, Doctor of Science, Olga Pavlova, PhD, Associated Professor of the Computer Engineering and Information Systems Department, Vitaly Alexeiko, a PhD student majoring in Information Systems and Technologies, and Andrei Kuzmin, a master's student majoring in Computer Engineering. The article addresses the challenge of forecasting natural disasters and reviews scientific literature to identify key parameters essential for predicting these events. It examines the impact of various climatic phenomena on human quality of life and the economic stability of affected regions. The most hazardous natural disasters are highlighted with an analysis of the damage they cause. The importance of developing forecasting systems is underscored, emphasizing their role in enhancing human well-being and supporting sustainable development goals. A mathematical model is proposed to pinpoint parameters that critically influence the prediction of different climate events. Additionally, a concept for a system that monitors and analyzes climate parameters for disaster forecasting is introduced. So, climate change and human activities have contributed to an increase in natural disasters, including floods, wildfires, hurricanes, and earthquakes. These events pose significant threats to lives and health in many regions worldwide. Effective forecasting can help reduce casualties and injuries by enabling timely evacuations and improving emergency preparedness. Predicting natural disasters also mitigates societal and economic impacts, which is crucial for promoting the sustainable development of regions and the whole countries. For accurate forecasting, it is essential to collect relevant data and indicators promptly for further analysis. Therefore, monitoring climate parameters is fundamental to successful disaster prediction. Statistics from the portal Statista highlight some of the deadliest natural disasters in recent history. For instance, the Hola cyclone in Bangladesh on the 12th of November 1970 claimed 300,000 lives. The Tangshan earthquake on the 27th of July 1976 caused over 200,000 deaths, and Super Typhoon Nina on the 30th of July 1975 also resulted over 200,000 deaths. More recently, the earthquake and the subsequent tsunami in Thailand on the 26th of December 2004 tragically took almost 230,000 of lives. In 2023, the United States saw the highest number of natural disasters, with 25 events recorded. China and India each experienced 17, Brazil 16, and both Indonesia and the Philippines saw 15. Pakistan experienced 13 major disasters that year. Asia also suffered the highest number of disaster-related deaths, accounting for 73.4% of global fatalities in 2023. Also, economic losses have been severe as well. For example, the 2023 earthquake in Turkey cost an estimated $34 billion in damages, while tropical storm Doksuri in Japan resulted in $25 billion in losses. It's essential to recognize that natural disasters often aren't isolated events. One disaster can trigger another one, underscoring the need for a comprehensive approach to studying and addressing these challenges. Let it denote the natural disaster as D and the climate parameters as P. Thus, the dependence function in its general form can be represented as a conjunction of parameters. In the context of natural disaster forecasting, there is often a need to monitor parameters for forecasting several natural disasters. For example, consider the functions describing the dependence of the occurrence of earthquakes and hurricanes. Since formulas contain some identical parameters, it is expedient to find the intersection of these natural disasters. Those common parameters for earthquakes and hurricanes are temperature, precipitation, and humidity. Picking on the slide represents the Euler-Venn cycles to visualize the common and distinct predictive parameters. At the same time, different parameters affect each of the natural disasters to a different extent. In order to interpret the impact of each parameter in more detail than binary Boolean algebra, it can be introduced coefficients that will allow to estimate the level of influence. Taking into account the fact that it is often necessary to make decisions in conditions of insufficient information due to the impossibility of analyzing all parameters, we will introduce a certain threshold coefficient T. To understand whether the analysis of certain parameters is sufficient, we compare the value of the function with the value of the coefficient. The threshold coefficient T for a natural disaster doesn't have a standard physical unit because it's a dimensionless value. It represents a combined risk score derived from various parameters, each weighted by an impact coefficient and normalized for comparison. Since T is a sum of weighted parameter values, it serves as a cutoff value. The value of threshold coefficient is individual for each natural disaster and can be calculated on the basis of previous events. The use of historical data will allow to determine the value of this ratio, and the analysis based on future events will be the basis for adjusting the ratio. For example, for each historical flood event, it is calculated the risk score, and then AI analysis of historical data detected that floods occurred when F is more than N. The concept of information system is presented on this slide. So, natural disasters forecasting is critical to saving lives, protecting property, reducing economic losses, and ensuring sustainable societies. The use of AI and machine learning technologies in natural disaster forecasting will help ensure sustainable development, improve planning, and operational response, which in turn will reduce the number of victims and reduce the risk of injury through timely response, development of scenarios to avoid negative consequences, evacuations, etc. Thus, artificial intelligence improves the ability to predict, prepare for, and respond to natural disasters, ultimately saving lives, reducing economic losses, and promoting sustainable development. The use of AI technologies for natural disaster forecasting is not only appropriate but also necessary to improve the efficiency of forecasting and timely response to hazards, which helps to save lives, reduce economic losses, and ensure the resilience of society to natural disasters. Thank you for your attention.
Thank you, Vitaly. It was interesting. Questions from audience. I know here there are some specialists in disaster monitoring. Maybe you are interested in some details. Okay, everybody is silent, but nevertheless, I have questions I should have. So you mentioned AI tools. Which models did you use, and to which input data did you use? Because it's known that AI models are inductive, so we should use some input data for training models and something like that. Yeah.
Okay, thank you for your question. Now we have only the concept, but we try to test our system, and we have data sets of historical data. For example, we have disaster and parameters which were monitored during this natural disaster. And then we can train our model. For example, we can use machine learning methods such as random forest KNN or more complicated such LSTM models. And then we detect some features, and after that we can calculate our threshold coefficient for our mathematical model. So we have input data, historical parameters, and output data, our threshold coefficient.
Maybe output data, it should be something like that. If you forecast something, you should forecast some event. Yeah. If you have a retrospective data, it's very good point, because you can play with input data in the past and try to understand which output provides your model. It's very good. If you can do it, it's beautiful. So thank you very much. Maybe any other questions to your colleagues? Okay, thank you very much.
Thank you.
Yeah.